Welcome back to our Scala to Spark class, and we are continuing our look at NoSQL databases. We are working with Cassandra, again a columnar database, and in some ways similar to a relational database, but in many ways also quite different of how data is stored. Again, used for huge, truly humongous data storage. Again, so this means that many of these standardized relational type of operations are actually not possible in this fixed time. So we'll look at some more commands, and also I want to mention a few things about the client. Again, we'll be working with Scala. There is theoretically a possibility to create a driver. In fact, I've done it before, but there is if you don't need a security certificate like the PEM file, you could set up a connection to using a dbeaver community version. I mean, assuming you don't have a professional version, it's possible, but it's a little bit of pain. So I'll mention you there is a Stack Overflow answer. You can try this. I mean, but the problem is it won't work because the PM file, there's no way of adding your security certificate right in dbeaver. So that's one way. There are some other clients. For example, I have not tested this one, so this is not official, by the way. This is just tools. This is some organization somewhere in India which has developed this client. It looks extremely simple, right? So this is my possibility, but you have to download the jar file. You need to build it, right? So it's a little bit painful. So this is also a possibility, right? So and also I found that there is also a very nice, again, requires professional version of IntelliJ. This won't work with the regular regular IntelliJ, which we are using. Again, you run into this problem that database tool window, view tool window database, it's not present in our non-commercial version, right? Community version again, right? So it's not here, right? View tool window, right? We don't have a database, right? We have service, we have some other stuff, but we don't have database connection. Again, so it's possible. So there's some alternative ways of working. If you just need data, you don't need to write a program, you just need to extract some data. It is possible to use some extra tools. Okay, but let's get back to, but we do have some code that's working, which is already good. So we want to extract some data. Maybe we'll also add some data. So what else do we want to look at? So we have a code with we have some object. We have a singleton object with some methods. We can get a session, right? We can run some arbitrary queries, and we also remember these queries. They will return a result set if you're using select, right? If you're not using select, you're using something else, maybe insert or alter. Then of course there will be nothing return as a result. But again, these are these helpful methods. Okay, and we only have some of these examples here, so we will try to do some of these ideas. Maybe explore these session commands separately. Maybe we'll insert some data. Maybe we'll create a table. Right, we'll look at that. And what else? Oh yeah, and maybe some of you might be wondering what in the world is this part here? Right? This because this is a way of indicating that this method could throw an exception, and this is of course here again our friend Alvin, right? This is a way to say, okay, you annotate your method. You say that what exceptions this method what exception can be thrown, right? You can also do multiple, right? You could say, okay, this can list all of them, right? So there's two ways. Why would you want to do this? First, you want to alert colors. It's like a good way of documentation, of course, right? Or also, this would be required if this method was called from Java. Again, not in our case, but that's why we don't have to declare it, right? But it is possible that this method could break. I mean, it could throw an exception, right? Again, Scala is not big on exceptions, right? But they are inevitable if you are working with Java code. Again, exceptions are, a little bit, make our life. They are needed oftentimes, but of course, handling them is kind of painful, right? So, for example, here, if you didn't get a cluster, for this, look at this here, right? there's a check on closing a cluster. If something broke here, right, you would actually get a null value. For example, if you didn't get a real working cluster, you would get you only close a non-null cluster. Otherwise, if you're closing a null cluster, then it would also be an exception there, right? So this is a little extra check, right? But here, for example, my methods, right? We're getting cluster, well, we're getting something, we're just saying we're getting cluster and session, right? And we're not checking exceptions. We could possibly get some, but again, it's a little bit quicker and a little bit dirtier, you could say. Okay, so we have code, and I have a nice resource for you. Now, where is it? Not here. There is something called the Free Code Camp, really nice place, and there is Cassandra. They even have a Cassandra tutorial. It's good for other things, but very good about these concepts. So we will see about these concepts. I hope what's happening with Cassandra. Why is it not working today? It's just open. I had it open. Interesting. My connection is working. Maybe I'll find it. Okay, there we go. Yeah, it's very popular. So, right. And so again, I already talked about this. Cassandra is distributed, scalable, right? But there's again, it's slightly, right? We don't have time to go through all this tutorial because this mostly describes the architecture. Again, if you had to design this database from the ground up, again, very unlikely you'll have to. Most likely you won't have to do this, at least not in this stage in your career. But you most likely will. You might need to read data. It's more likely you will have to read data than create a completely new Cassandra database. But again, we'll see what's the idea. Again, is this partition, right? So again, setup. Again, we don't need setup. We already have database running. We skip that step, right? It's possible to install it locally. I told you, right? You can run queries locally, right? 3 nodes, right? So architecture again. No node is superior to other nodes, right? Like I told you 2 days ago, every node is basically like a controller, basically, right? So again, so if something goes wrong with one computer, with one node, no problem. Well, usually no problem, right? If you have lots of nodes, right? With 3 nodes, you might run. If 2 of them die, it probably also will be a problem. So, replication, right? So. Whichever node gets the first request, right, becomes a coordinator for that particular request, right? So they say, okay, every node coordinates different requests, right? You say one, you request one data, right, and it becomes whichever node was serving that request, right, coordinates that. This possible other node for different requests, right? You're reading different. Your app, this is your program, of course, right, running, and so that's what's happening underneath, right? So everybody's equal, right? Every computer is equal, right? But again, the idea, again, we'll run into this partition, right? So we have some sort of schema. Again, we'll have tables, right? So it's a little bit more complex than using SQL, right? So we are required to have a partition key and possibly a clustering column, right? So again, this will be an example here. Let's look at this example. If you have a table, right, that you say you have a partition key, and you say, okay, you might want to just email. Again, of course, everybody has to have their unique email, right? But here you want to say, you also want to, it's required you have a partition key. In this case, it's going to be a country, which we're going to use as partition. So what does it mean? Of course, that, well, this lookup by the country will be optimized because there will be a partition. So we'll see about, we'll create this table. Let's try this, right? We'll create this table, see if this works, right? And see if our query works, right? So again, notice here the double parentheses, right? So this means this is the primary partition key is country, and again the cluster key, right, is user email, right? The clustering key, right? Clustering column, right? So anything else, right? You could have more, right? More. So partition key, on user email. So let's try to do this, and it should work, right? Let's try it. We'll put it in here, and of course I'll do day 15. Day 15. Source. Scala class. Object. Day 15. And Cassandra CRUD. Right. Again, I'll do client. Right. Object. Add. Extends app. Right. So what do we need here? Do we need anything else? We need basically this part here, right? Maybe nothing else, right? I will read all of this. We will need all of this good stuff here. Right. So admin, my port, again this is different for you. Again, you could store it in a system environment. Again, should do store host and port also in system environment, right? Again, it would be a good idea again, so because there's no need, of course it's not a big security risk, of course, assuming you have a good password which is really long, right? But again, if somebody knows you have password, they could just basically maybe attack your, just basically denial of service attack, right? You know, there's no need to publicize this if you put in a Git, right? But again, of course, this is not so no need for outside parties to know your host address, right? Again, it's not it's again, it just gives you a target, right? So without any need, right? So that's something you might want to do for your system environment. Okay, so we'll want to have a query like this, right? Create table, and I'll adjust this a little bit. And what else? We want to have a connection, right? So host no, we won't run this one. We will want to do get a session, right? So we will want to get a session. Let's see if we can get a session, right? This will be our session. Let's see. And do we close it? We will want to close it also, right? Yeah, okay. And I will close it, right? So again, so you can use this Cassandra example in any of your code, right? We have some helper methods, and we can use this, right? So we import get cluster session. That's our method, right? And I can use it now. Let's try. And of course, I need to close. I should just close it, but I'll just do session close or cluster close, right? And maybe I should make a helper method, but I'll just do cluster close. Right? Okay. Closing. We'll close or cluster. Cassandra cluster unclosed, right? Let's see if this is actually connection should be closed now. Okay, let's see if this runs, right? So we use session for what? We used for making queries. Cluster is actually the big connection here, right? Notice how we did it here, right? We return both, right? It's just for convenience. It's just for convenience. Okay, let's run it, right? Opening up. We'll open up. Opening up a connection to Cassandra cluster. And let's run it. See if it works. Compiling, right? Shouldn't take too long. Let's see. Going to connect. We'll close. On. Yes. You see, it took a couple seconds, but looks like everything worked okay. I should probably check what happened here. We can check our cloud instance. I'll connect, sign in. And check also my credit, right? It's running, so we'll have some money. Again, looks like internet today there's some congestion online. Again, that's a part of your life, right? If you're using resources from outside, right, which are somewhere else, right, takes a little bit longer, right? It's running, okay, great, it's running, so looks okay, right, looks okay. Let's look at some metrics. What's going on? Did you have any unexpected? Looks like nothing big, some jumps, right, but nothing too bad, right? So looks okay. Again, operations percentage-wise, this is less than 0.1%, so nothing. So there's no load at all on this. Right, I have 3 weeks remaining on our trial, and I have 17 credits, so like $17 used up from yesterday. No, from 2 days ago. Okay, so okay, everything works. So let's create a table. Let's create a table, and our query will be right. So we'll do. We call this run query, right? So run query. I'll do create table, table creation query, right? And I'll do maybe triple. Yeah, I can just do this, I guess. Yeah, I'll do this, right? Easier, right? You could do on, yeah, we'll do that. And where's our tutorial? We'll do this one here, right? It should not, we don't need the semicolon, pretty sure we don't. We can skip it. But let's see if we can adjust this. Okay. And so, country, user, and email, I'll call it users by country, right? Again, so learn Cassandra. Again, this is just a subdivision, so create table, right? So question is again, notice here, right, get cluster session. Right, we need a key space, right? We need a database, basically, remember? Right, so, and what's our key space? We'll need to have a key space. Run query, example key space, right? So example table, right? So questions, could you make a new example database, right? Could you make more, right? Could you make a new database? Let's try that one. Cassandra, create new key space. Do we have, can we do this? Wouldn't that be nice? Let's take a look, maybe let's start with that one. Maybe you want to get a new database. But maybe it's not use create key space, right? So that would be the query, right? So that would be the query. We'll call this one here, right? A database. You can actually create a new database. Again, topology on data center. Let's see, data center 3. That was. We need a name also. It's again, so you need to look up a name. This won't work. You would need to check up the data center name, I guess. You need to do some other things, right? Again, maybe we can check the data center here. Let's see, overview. Yeah, Ivan. Okay, Ivan. Okay, yeah, Ivan. This one is Ivan. Okay, let's try this. Let's see if it doesn't work. No big deal. We can use the old database, but let's try making a new database. So this is actually we'll call it. We won't use even database here, right? So raw query. So we'll do raw query, and we will basically do this, right? This will be just session. We just need a session, and no key space because that's not we might not need it key space, and basically it's basically just a very simple wrapper. It's going to be a result set, but again, it might not need it, so just basically session execute, right? Come on. What's happening here? Why don't I see it? There's an extra parenthesis. Yeah. Okay, session execute on query. Right. I mean, you could skip this part here, right? So this will return result set if select, right? Okay. Okay, otherwise it returns nil or null. Okay, raw query method. So we will run it. All right. That would be table. So the key space creation query. So key space creation query, right? And again, what will we use? We will use this official one, right? Let's try this, right? So create command, right? Copy, right? So right, of course this is shell command, right? And again, not cycling, but we'll call it my database, right? Or my key space, right? Or I'll call it VS key space, right? I'll call it VS key space, right? Again, just an example key space, right? It's replication. So this should be Ivan 3, right? That should work. Let's see if this works. Okay. So let's run it, right? And then we could list database. Let's see if we can also command to list these databases, right? This might be also useful, right? So we have raw query, session, and key space question query, right? Okay, it won't get anything back. Let's see if this works. Again, we might get a nice nasty exception here, right? So create key space if not exists. I'll call it VS key space. So VS key space, of course. So instead of key space, VS key space, we could use any name for our database, you know. Okay, key space, right? Okay, let's see if this works. Maybe are we allowed to make a new one? Let's run it. So raw query, and let's run it. No exception or yes exceptions? Looks like it worked. Okay, good. So we should have this key space, right? Okay. Yes. So now we should have this key space, right? So closing it. I'm not going to run it again. I mean, it should be empty. I mean, if not exists, right? So I mean, it will do nothing. This will do nothing. Should do nothing if key space is already present. So I'll leave it in, right? It should not do anything because we have this qualifier, right? So I'll leave it in just for testing purposes, and we'll do this table creation. So this will be users by country. So we'll use this run query. What do we call it? We call this run query, right? So run query on session, of course, right? And run query. What else do we need? We need, of course, key space will be VS. So you insert yours key space, right? So different database, and we'll do table creation query. Okay, okay. I need to import it, of course. I need to import it, right? So notice here it's imported, right? From my example, I import this particular method. Okay. So raw query on insertion query. So we create a new table. Yes, there was no if not exists. I forget if there was no. Okay, so country text, user email, text, age, small integer. So primary key will be country, right? So not user ID, but so that's one of those things, right? There's no primary key like we use in our databases on like in MongoDB or like in SQL databases, right? You need to set up this partition key, right? So this part here is going to be the partition key. Okay, let's run it. Let's run it and see if this works. Let's see. Okay, looks okay. Let's check our stats. Doesn't show much, right? The stats are not really, right? Some little blinks, right? Again, I mean, really tiny. Okay. All right, so we have a table. Now what will happen if I run it again? Will it work or not? Let's try this. Because this part will be no problem, but this table creation, we can't create table which already exists, right? Yeah, indeed. You see, you get a nice little red warning, exception, on which of course was table. You see, this is so already exists, right? So that is, and again let's double check Cassandra. Create table if not exists, right? So this is, I think I checked this, right? It's not. Oh, there is actually. Okay, let's add this, right? If not exists, yeah, let's add this, right? So that might fix the code, right? So this will be if not exists, right? Okay, good. Let's run it. Okay, so we have nice 130 error, right? No exception, yes. Let's run it here. Again, I know it's a little bit painful to work like this. That's why if you have to write many queries, again, this is your... Right, what they do here? What they do here? Let's see. Let me see. Wait, let's create table. Yeah, no, wrong. Like this, you have to be right. Okay, stop. Okay, right? No problem, right? So everything works. Okay, so these two again will do nothing. Will do nothing if users by country already exist. Okay, great. Okay, so these two queries again, raw query, run query. So let's start inserting some data, right? We want to insert some data. So, well, we want to run it like this in the, maybe they will mention here example, right? So partition key and clustering key. So we want to insert some data, right? So this would be a raw function, right? Right. So, right. So again, it's different from traditional relational database tables, right? So your partition country is again, if you decide that this is important, of course, right? This partition schema that you don't have this just a regular ID or something, right? You use a partitioning as part of your it's a foundation basically for your way of scaling the database, right? So something like this. Notice, right? So US, right? Look at this picture. US lives in one partition, right? And UK lives in another partition. Okay, right? So let's add some data, right? So we will want to, again, the best way to do this, right? This is, of course, if you control the data, this is fine. But if you don't control the data, if you accept, if you want to know, if you're not sure if this data is sanitized, if it's safe, right? You use something like this, right? You use this way of binding, right? So we'll use this again, right? And so we will need to rewrite this, right? And I will basically rewrite it. It would be nice, of course, to write a nice little, a script for doing this, right? So query, right? And values, right? And of course we have how many values? One. None of these are required, by the way, right? So, well, again, it's so. Of course, So we'll need to, of course, use users. So I'll use this. Insert into what? VS key space, right? Right? Because I'm not using it. So I didn't say if I'm using it, right? So this will say, okay, I'm using this database, right? And users by country, right? Users by country, right? Like something like this, right? Okay, let's see, can I do more? What happens if I do this? And yeah, I can, actually, I can. Oh, thank you. Thank you, Intel J for this. That helps me a lot, right? So, and I'll need some values, basically, right? So this lets me sanitize this, right? Parameterized, right? Right. So, how many values do we have here, right? Yeah, I'll make it, so this is a safe way. Again, if you know the data is safe, of course you can skip this step, but again, generally you don't want to skip it. So where is my, all right, so key space, where's my, what happened here? Okay, oh yeah, so John Wick, right? Peter Clark, right? So we have 1, 2, 3, 4, 5 values, right? So it means we need to so like this. Right? Yeah, okay. And I will skip this part here, right? So, and I will want to. So 1, 2. So insert into not again. This is VS key space, right? Yeah, that's mine. You know, basically my one, right? And again. Right, values, right? So we don't need this one. So how many question marks do you want? 1, 2, 3, 4, 5, right? So that should do it. Again, so this is a safer recommended method whenever you don't have the data you can trust to insert, right? So, all right. Okay, 1, 2, 3, 4, 5, and now I need my values, right? So now I'll get the values. So where are my values, right? I will get these here, right? I'll just skip them and let's see if this works, right? So it should, because this is arguments, unlimited number of values. No, it knows it comes from Java. Cancel. Yeah, okay. Ah, right. Yeah, sorry, Control Z, Control V. Okay. Oh no, Control Z, no, Control Z. Okay, what happened here is it's using single quotes, right? Because this is in CQL, right? So I need to rewrite this. I will need to rewrite this, unfortunately. Okay. So cancel. So I need basically to convert to no. It thinks it's character, so it's basically just a double quoting issue here, right? Right, because these are strings. Remember why? Because in Scala, double quotes are strings, single quotes are for characters, right? Not every language has this distinction, right? So we need to convert this. And now it should work. So John Wick, right? 1, 2, 3, 4, 5, right? And let's do some more, right? Again, I'll do maybe one more, right? US, or not Control Z, no, sorry, like this. So let's do this again. Control D. Yeah. Okay. Right. So I will do UK and Mr. Bean maybe. Right. I don't know. 65. Right. Right. Mr. Bean. And UK 1, 2, 3. I don't know what his first name is actually. Right. I'll do, of course, Rowan. Right. I'll do Atkinson or something like that, right? Okay, right. So let's see if this works, right? By country, right? We have 2 country. I'll do on Latvia also. Why not, right? So we have 3 partitions. We have 3 partitions. LV, right? I don't know. Again, KK Christian Karinch, right? Something like that. Right. And of course I could do, let's add some Latvian letters here. Again, maybe, let's see if we have any problems with that. That's also something good to test. Karinch, right, okay. So, and then of course, again, Krish, right, again, those words from Lithuania, of course, or Prime Minister, right? So, okay, I don't know, but around 60, okay. All right, so we have some data. Again, fake email, right? Example.com, of course, right? You could use example.com, right? Email.com. I think email.com actually is real address. Let's try it. I think somebody owns email.com. Not secure, right? Yeah, you can buy. This looks very not a good address. I'll use example.com actually, because example.com is officially real example address, right? Meant for testing, right? I don't know who actually. That's officially sanctioned address, right? Okay, right. Okay, so we have our data. Let's see if this runs, right? Session execute, right? Notice I'm using database here. Well, let's run and see if this works. If it doesn't, we'll check. Do we have any problems? Oh, we do have problems. All right. So, what happened? Right. Okay, I have feeling 2 bytes for small integer. Okay. Something happened with our data type. Small integer. Oh. So. Looks like this part here is problem, right? Age is a problem. 1, 2, 3, 4, 5, and this was not. It gave 2 bytes, and I think what happened here, right? So the problem is this wants to we'll need to convert this really slow to to int. Can we do to int to double? Yeah, maybe. Can we create a new one? Let's do drop table, and let's do this. I'll just do int, right? Because this again, I'll just do int, right? Because I'll do drop table, and I'll drop the table, right? Let's drop a table as well. Let's learn the dropping table too, right? Cassandra drop table, right? And this is, let's look at official document. Let's use official documentation. Drop table if exists, right? Yeah. Yep. Let's do it. I'll drop it for now. And again, of course, I could just session execute, of course, right? Raw query. All right, I could do this as well. I could just run session execute, of course, right? So I don't even need this, right? Session execute, and I'll do this basically, right? Cancel, right? On if exists, right? And of course, I'll need to use this. All right, key space. Yeah, key space. Right. So we'll want to drop this part here, right? Right. Dropping table from vs key space, key space database, right? Okay, right? Semicolon, we can skip it, right? Okay. Now let's see, and now I'll just do so let's check our Cassandra data types, right? Data types again. It's so we check. There's a blob. So big int 64. I think just the int will be fine. 32-bit signed integer. That would be fine, right? Again, if you, of course, if you're storing a huge amount of data, you might want to take small int is only 2 bytes. Again, I don't really want to mess with 2 bytes, so I'll just go with the easier version. But okay, before I do this, let's before I do this, right? Small int, right? Right. This will do nothing, right? So can I go to 264 Scala Scala to small int? Can I do this? Can I do this? There was maybe, okay, we want 2 bytes. So that means short, okay, short, okay. It is possible, right? So short, right, to short. So this is, how do you cast it? We'll try it. If this works, we'll fix it, and then we'll go to actually fixing it in a, so it is possible, right, to go to short, and how to cast a short. Let's see, so I would need to have a, right, so here, can I do short? Yeah, okay, it's possible. Okay, let's try this. Right, what this means is, because by default we have at least 4 bytes, right, but we are going to short, right? Okay, here of course is still small int, right? It's still small int because, why? Because this is this is not run, right? So it's not gonna nothing is gonna happen here. Okay, let's run, see if this works. Then okay, we stop it. Looks like it worked. Okay, great. All right. So in this example, it worked, right? But we could also, of course. So I could. What happens if I go to integer? That's a good question now. Right. So I will add this small command, drop table if exists, right? Right. So this means it will go to integer, right? So this we expect to have some problems here, right? We'll see, right? So it's looks like Cassandra is very specific. If you give too little data, right, it will cry, right? So we'll need to get rid of this. This is too short. But again, good example. See how data types, again, testing data types is important, you know, when you're working with database or working with data. Right? Again, so this short is 2 bytes. Regular data is, of course, let's see here. I'll give this here. We need to convert or default int, which is I think is 4 bytes or I think 8 bytes, possibly 8 bytes, right? I think, right, 2 bytes, 2 bytes short, right? I think it's 4 bytes. I believe yeah, it's 4 bytes, right? To 2 bytes short. Okay, because Cassandra, because that column requires 2 byte integer. Okay, that is the problem. Let's see what happens now. Do we need to convert it? Will we have a query exception? Let's wait. Yep, we do get an exception. Now I expect, yes, you see, expect the 4 or 8 byte integer, but I gave them only 2 bytes, and of course we get an exception again. So a little bit tricky. So how do we fix this? Simple. I will copy this all, right? Control D, right? And of course now I will leave this in as an example, right? Right. So now if column is regular int, then we give it regular int, of course, right? So nothing too complicated, but again, something data types, again, these type of errors, again, when you're transforming data, relatively common, right? Relatively common occurrence. So let's run it again. Okay, looks fine. Okay, we fixed this. So again, let's go back what we did. We are dropping table. Otherwise, I'll stop this again. So this is we drop the table, the old one, and we create a new table. And the age was an integer. Right. We could also put something else. Maybe put some, I don't know, some long as well. Put some other type of data. Right. And we added some users, right? And we have 3 partitions. Yeah, right. Again, so 3 users. And now, of course, we will want to read the data. Again, this in each insertion, right? It won't be so unlike SQL with where primary key is usually inserted automatically, the above queries would keep adding more data. Here we just have the three rows, right? And that's, you know, on also 3 partitions. Okay, maybe let's add one more Latvian, right? Or maybe Lithuanian, right? Why not, right? Or I don't know, maybe English. Let's add one English. We'll add our departed. Again, I don't want to think about it, so I'll add Boris Johnson, of course, right? Why not? So Boris Johnson, why not, right? Again, probably soon to be forgotten, maybe. I don't know. 58, I don't know. Mr. Boris, right? Right, okay. So 4 partitions, so we had 4 rows and 3 partitions, right? And so 3 partitions, right? US, UK, LV. Okay. Maybe we get some different Lithuania, maybe, right? So I want you to add also, probably that will be one of your requirements, to add somebody from Lithuania and from Latvia, right? And then we'll need to do some selection, right? So let's run it. Yeah, everything worked fine. Again, these parts, of course, this is just that's just cosmetics. Okay, so how much time we have? 45 minutes. Okay, we have been running a little bit late, so that means I will do selection, of course, right? Get data, right? And of course, users, right? Or well, users, right? User results, right? Will be right. So this will be or select. So again, a session query. I'll do a session execute, right? Select all from VS key space on the users by country. Okay. And of course we can do user results for each row. Can we print it? Print line row. Right. This will be what row, right? Yeah, it is a row. Okay, let's see if this works. Okay, so yeah, fine. Okay, works fine. Okay, great. All right, so what will be your task? So to do add two more users, one from Latvia, LV, one from LT, right? Okay, and let's see if this works only, and then return Latvian users, return Lithuanian users, right? Okay, and what do we want to do? Again, if you have time, we won't have time because we're running late. Ideally you would not only print but save the users into a case class, right? You know, case class user, right? That would be, of course, be great, but that's something we might do. If not, we can look at that later. Okay, so that's your to do, right? Add two more users, right? And return Latvian users, return Lithuanian users, of course, right? So simple stuff. All right, thank you, and we will continue as usual at 9.